Hello AGD coders, welcome to another video, and today it's just a quick one. We were talking on the Facebook page about jumps and how to determine whether the player is in the air, what position they're in, and so on, and there were some nice solutions, but it got me thinking maybe we could actually read the jump table itself. And as you can see here, that is basically what I'm doing to create this animation, to know if the block is moving up or down or not jumping at all. And basically AGD has a couple of extra variables apart from the param A, param B, direction and so on. There are a couple of extra ones which we don't normally have access to, which control the jump, and it basically tells AGD the address of the jump table. So it's held in the IX register, so all we have to do is load IX plus 13 and 14 are the two addresses that we need, but we only need the low number because that's the number that's going to tell us the position of the jump. So yeah, what we do there just with this assembly code is we load it into the variable opt. Now rather than assemble this and load it into the char set as a binary file, it's such a short piece of code, it's literally only 6 bytes. We might just as well put it into the code itself directly with single ASM numbers. So when we assemble it, it basically comes out as these 6 numbers here: 221, 126, 13, 50, 54, 125. So because it's only 2 commands, yeah. The first one here loads A with x plus 13. In fact, if I just slide that across there, you'll see. So load A, IX plus 13, that's 1, 2, and 3 there. And load opt with A is 50, 54, 125. So it's basically it. And that will give us the one of the pointers for the jump table address. Now this jump table basically carries a number. If it's 0, it means we're not jumping. If it has any other number, it means we are jumping. And so we can test immediately. If opt is 0, that means we're not jumping. So that's test 1. Second test has a number between 142 and I think it's 161, something like that. If you count the jump table steps, you'd be able to work it out, but it's more or less that, I believe. So those numbers basically means 142 means the first part of the jump, 143, 144, 145, and so on means normally it means that the player is going up, and then when it reaches the middle section, which is here around 151, that means the player then starts going down. Of course, it does depend on your jump that you've created in the jump table. So a shorter jump, a longer jump, and so on, it could be different, but those numbers in the jump table basically correspond to that. So simply by reading that number, by knowing here I've set object 0, that means not jumping. Image 0 I should say. Image 1 means between 142 and 151, which means that it's going up, and then bigger than 151 means that it's going down. So basically this will allow you to precisely read exactly what point of the jump the player is in. So you could write some fairly complex code with more animations and different things if you wanted to give it a go. And essentially that's what I've done here. So as you can see, I've taken the sprite from Andy John's game Ooze and made some modifications. And as you can see, this sprite has several frames of jump animation, including one there for fall too far. So you can see it sort of curving around as it jumps. So yeah, let's take a look at the sprites themselves. As you'll see, there's just a standard sprite there moving right and moving left, just 3 frames each. And then we've got another 2 images here with our 4 frames of animation, 5 frames of animation for a jump to the right, and this one here to the left. So you can see as I'm flipping between them, there's a sort of mid jump and then another one for as it falls, and then a final one for when it's falling too far, falling straight down. And within the player control then we've got the same code here, this set of numbers which basically gives us our jump table position. we've got the usual sort of test. I'm setting image 0 and 1 for key 1. Then I'm running a test here to see if the image is greater than, or I should say less than 2, and if opt is greater than 0. So that means if you're in a jump and you are below image 2, in other words you haven't gone to jump image yet, then go to the jump image and set the frame back to 0, and then run a test on the opt value to see where we are in the table, and we'll use frame 1, 2, 3 and 4 here. And then if we're not jumping, we'll also check to see if the frame is greater than 3, because there are more jump frames than there are walking or shuffling frames. And we've also got here checking if image is greater than 1, so it means if you're in the jump image, then go back to the walking image. So it's a little switch. Basically, it just tests that one time from when the sprite transitions from sort of shuffling or slithering to jumping, and that allows us to switch freely between the two images. So yeah, that's basically how that works. Now there are a couple of other things we can do here, and one of them is to implement a double jump. And what you do here, as you can see, I've looked at key 4 and I've checked if it's above 150, so a certain stage within the jump frame between 150 to 156. So in the middle of the jump at the top, we can test for that now, and we put stop fall in there, and it will allow us to create a jump. So basically when we jump at the middle point, we can basically do double, triple, quadruple jump. Now the issue there, of course, is that if you hold down the space bar or the whichever key you're using for jump, it will continue to jump and jump. Now that might be something you want, you know, something, perhaps some kind of flying mechanism or something like that. But what I've done here, as you'll see, is I've put a test in using a variable. Here I'm using j, setting it to 0. If you just pause the video if you want, but I'm setting it to 0 here, so that we can only double jump once, basically. So it tests it. It resets the variable when the player is in the air. So therefore, it will only happen once, and that variable will go back only when the player is back to the walking mode. So as you'll see, that's how that works. We can only do 2 jumps in this case. So again, I mean, you know, play about with the code. I'll make these demos available as part of the Dropbox download for this episode. And yeah, so basically you can see here just one double jump. So you've got complete control over the jumps now, really. You can do double jumps, triple jumps, change the animations, run some tests, and in fact you can also use it to create new control methods. And I've done another example here, which is a kind of swim mechanic. So as you can see here, you can swim up and then he'll fall very slowly down, and you can sort of swim about and move, and there's a kind of underwater effect. And I've added a little bit of trail when you actually jump. And the good thing about this, of course, is that the sprite just behaves normally when it hits a ledge or something, or the bottom of the surface. So it feels very natural to the player. It doesn't feel awkward or tricky, and it works pretty well. And you'd use a different jump table to get this kind of effect, and I'll show you that now. So the first thing we do then is we'll just jump back and go to the jump table. And as you can see, I've got a little hop, and then a slow rise, and then a slow gentle fall, and that's how we get the effect of it being in water. And all we do is we just use the same code. The only thing that I've added, as you'll see just here, is when it's in full fall mode, it's normally frame 4, but I've also got left and right here to frame 2. So it means that the animation frame will lift up the sprite a little bit instead of just falling straight down if the player is moving to the left or right. So that's basically the principle of that. Again, pretty straightforward. as you can see, if we just go back to testing, basically it will move up, and there you can see the trail effect, and then it will slide down, and if I move left and right, and when it lands on a platform, it's fine. Okay, so that's pretty much it really. As I said, I'll make the code available. It will be the AGDX 4 beta that these are made on, so you may have already downloaded that from the Facebook page, but just be careful because it might not be 100% bug free. You can't guarantee it, but it'll be enough for you to get an idea of the code and how to implement it into your own games, I hope. Okay, so that's it, I think. I hope you found this useful. Please like and subscribe, and keep enjoying the Spectrum, and as always, happy coding. Thanks a lot. Bye bye.